Isotopes. So all atoms of the same elements have the same number of protons. So we've talked about atoms, we've talked about elements, and as you add protons or increase in the number of protons, then you're changing the type of element that you have. Well, isotopes involve when you have the same element, but you have different versions of that element. So you're not changing the number of protons when you have a different isotope. Instead, you are changing the number of neutrons. And by changing the number of neutrons, you'll have a different isotope. And so, as a result of having different number of neutrons, you'll also have a different mass. And so, here we have three isotopes of carbon. We have carbon 12 and carbon 13 and carbon 14. Now, you'll notice that all of them have six protons, and six protons. If you have a different number of protons, you've got a different element, and it wouldn't be carbon. All carbons have six protons. What's changing is the number of neutrons. So carbon 12 has 6 neutrons, carbon 13 has 7, and carbon 14 has 9. You'll notice these percentages here, and these are called relative abundance. And we'll dive deeper into that in a little bit. But for now, just know that relative abundance is the amount of that particular isotope you would have in a random sample that you find on Earth. So if you randomly find a sample of carbon and you look at it, 98.9% of it would be carbon 12, 1.1% of it would be carbon 13, and less than 1% of it would be carbon 14. So now we're going to dive into looking at isotopes and looking at kind of building and making different isotopes. All right, so I have here hydrogen. I have what's called a neutral atom because I have the same number of protons and electrons. And here's hydrogen. If we look at the mass of this particular isotope, it is the sum of the protons and the neutrons are 2. Now, if I add an additional neutron, then you'll see that the mass number goes up. So when we refer to isotopes, we actually just use the mass number in order to refer to that specific isotope. So hydrogen 3 means that the hydrogen has a mass of 3, hydrogen 2 has a mass of 2, and hydrogen 1 has a mass of 1. So now I have lithium, and you can see that it's lithium because if you look at the protons, there's 3. So having 3 protons means that you have lithium. And because there are also 3 neutrons, we call this lithium 6. So if you increase the number of protons, it changes the element. In order to have an isotope, you can't increase the number of protons. You have to have the same number of protons, but a different number of neutrons. So lithium 6 is one common isotope of lithium. The other most common is lithium 7. So if I add a neutron, you'll see that the mass number changes, but it's still lithium because it still has 3 protons.